Okay, so today we are going to look at a truck. The customer is complaining of all kinds of weird transmission concerns, won't go over 45 miles an hour, whining noise and all that. And the transmission guys already looked at it and decided that there's something wrong with the engine. And so we're going to investigate that here for a minute. So like I said, it's a 2016 F150. There's the VIN tag for your test sheet. And she has 91,253 miles on her. So where I wanted to start with this truck would be we want to pull codes, and I thought that today would be a really good day to take some time, and I'm going to show you how to hook up the IDS and what the IDS is all about. IDS stands for Integrated Diagnostic System. In other words, we're integrating all kinds of different things into one diagnostic tool. We have the ability with this unit to just pull codes and look at PIDs and look at stuff in the computer, but we also have other units that we can hook up to this system so we can check pressures and voltages and all kinds of different things. And this purposes of this class is not to try to teach you everything about the IDS itself, but I wanted to give you guys a rundown for you guys who have not done this before. So let me start with a hookup, and then we'll come back around here and we'll talk about how to program it into the computer. So from inside the vehicle, every vehicle is built since 1996 is going to have what they call a DLC connector. That's a data link connector. Okay, it's a 16-pin connector. It's the same connector for all manufacturers. Not all the pins are the same for every manufacturer, but there are certain pins that are, and we can discuss that in a different class. But we have the connector here from our IDS system. We're just going to simply plug that into the car. We're going to turn the key to on, which I've already got it on, and then we're going to go out and I'll show you how to boot this thing up on the car. Okay, so it's really simple. All we're going to do is we're going to come to the start a session and all other vehicles and enter. Wait for it to do its thing, and it's going to boot itself up on the car. Okay, it'll pop up and say what car it's booting on up to, and then it's going to ask the question, is this correct? If it's not, it's going to assume that there's something wrong with the programming and kind of take us down a different route, but we don't really care about that right now. We just want to hit yes. This is the car that we're looking at. Okay, so now we're booted up on here, and you can see that it is a F150 with a 5-liter with the TI-VCT. That's the type of VCT controls that are on there as far as the variable cam timing. It's federal emissions. In other words, it's not a California vehicle. It's a 2016, and it shows the mileage and the VIN number. Okay, so from this menu we can pick the toolbox, and we have lots of things that we can choose to do with this car. Easiest of which is just to do self-test on the vehicle. We can self-test all the different modules, or we can do a continuous code or continuous tests to all the modules, or we can come back up here and we can look at the data stream and see what's happening with all the different parameters in the car. We'll cover that a little bit later. We can monitor the network. We can program the module. We can do network tests. We can do all kinds of powertrain tests, and which we'll get into later on this semester. We'll cover some more of these. But for the purpose of this, I just kind of wanted to show you how to boot up on here. So what we want to do right now is we're going to do a self-test. And I want to do a self-test particularly right now on the engine itself. So we can choose on-demand self-test and hit enter, and then it's just going to have us go through a series of preparations for the vehicle, make sure that the AC's off and nothing's in gear and that the car's not running and that kind of stuff. It'll just tell you what it wants to do. So now we're going to go through a self-test. Okay, you could hear it ran the cooling fans during the self-test. It went through a whole series of stuff inside the dash. But here we are. And what do we ended up with? Well, obviously I didn't turn the air conditioner off because the top code here is the AC was on. So we can ignore that. But we have a continuous code P06DD, which says that the oil pressure control circuit performance is stuck off. Okay, now we need to be able to go to the workshop manual. We're going to work through that particular pinpoint test and find out what that means. Now, up on the top, when we do our IDS, when we do self-tests, it's going to give us if this code has any TSBs associated with it. It's going to pop them up so that we can automatically know that, hey, there's a bulletin on this, some kind of a problem that Ford knows about. But if we just read the literature on that right there, it says 2016 to 2017 F150 with a 2.7 engine. But as we recall, if we went back over here to what this car is, it is a 5-liter. So we know that this technical service bulletin does not apply. Okay, so we're going to try to interpret what in the world's going on with this. So the next thing we want to do is kind of do a visual inspection on this truck and find out, you know, it's got some weird noises, it's got an oil pressure code problem, don't know what's happening with that, but we want to do a visual check. We want to make sure that it's got oil in it, we want to make sure that there's no giant oil leaks, that it's got coolant, and just look, we just want to look for anything obvious, no rat's nest any place in here, anything like that. So let's pause it and let's do a little visual inspection. Well, so in the visual inspection, one of the first things we notice is that it says it has an oil change required message on the cluster. Okay, so that's kind of a clue as to maybe this thing's past due for an oil change and its maintenance. Next thing we notice in our visual is that the oil change due sticker says 87,500, which makes it about 4,000 miles past due for an oil change. So one of the first things we're going to want to do is climb up here and let's check this oil level out, because he's obviously really past due. Let's check the quality of it. So when we check the oil, we're going to pull the stick, we're going to wipe it off, we're going to drop it back down in the hole again. We're going to see that there is really low on the stick here. I think you can see that. If I can try to focus in on that a little bit. I don't know that I can. Trying, guys. I don't know why it's not. There we go. How about that? You can barely see any on the end of the stick there, okay? So that's not a good thing. So let's continue on with this visual inspection. Okay, so we're going to look up in the PTS website what's going on with this P06DD code. So this is the home for PTS website. We're going to come up here, we're going to pick a vehicle, we're going to drop the VIN in, and we can put that code back in here, remember? And what that's going to do is it's going to pop up. Okay, so some other things that we're going to find on a visual inspection about this car is it's a Canadian vehicle. It's not an American vehicle, which doesn't usually affect us too much, but it may have some warranty things we need to be aware of. Okay, but we can come down here to the bottom, and we can look up that code. Remember, that code had a tag on it in the IDS that said that there was a TSB involved with it, but this system realizes that this car's got a 5-liter, so it doesn't have anything to do with it. Okay, so this is going to tell us, the PTS website is going to tell us everything about the car. It's a 16 F150. It's a crew cab. It is a 5-liter modular motor. There's the engine calibration. It's going to tell us what transmission's in it, a 6R80. It's a flex fuel vehicle. It's going to tell us it's an F150. It's going to tell us 4-wheel drive, axle ratio, tire sizes, paint color, all the information we need to know about it. We can find out its warranty start date, when it was birthed, when it was built, and so we can find all kinds of information about it. We can also find out if there has been any warranty history. We can see what's up with that. We can tell all kinds of things about it in here. So it's a really important page for us to get familiar with. Okay, so we're going to come here to the PECD, and we can choose diagnostic trouble code charts. We're going to come on down here and try to find P06DD, and it's a good chance that it might be in the engine and not in here. P06 DD, some more, P06D1, no. Okay, so it's not in here. So we're going to have to come over here, go to the workshop manual, and we're going to go to engine, and we can come, I think we're going to have to come down here to engine, electronic engine controls for a 5-liter, and see if it's in here. And this should pop up. Diagnostic trouble codes in here. P06DD, engine oil pressure control unit stuck off. Okay, so it's going to take us to go to Pinpoint test D. Okay, if we pop up here a little further up, we can get a description of what this code is. Okay, it says oil pressure control solenoid faults. It tells us to refer to wiring diagram, and that's pretty much its description. If you come down here to the actual code, it says this sets when the PCM detects oil pressure control solenoid valve is stuck. Okay, so it's saying that the pressure control valve is stuck. Okay, what this engine has is it has a variable oil pump solenoid, so that we can reduce oil pressure at higher RPMs to reduce the load on the engine, give it better gas mileage. Okay, so it says we can have this possible sources are that we could have a stuck solenoid valve, we could have a bad PCM, or we could have wiring or terminals. Okay, so it's going to have us go through a series of tests. Key on engine off, disconnect the oil pressure control valve, solenoid valve, and then measure the voltage on it. And we're going to go through this pinpoint test and see this happen. So let me pause this for a minute and we'll take it back over to the vehicle. Okay, so we've gone over to the car and we've checked all its circuitry, and I'm not going to, the purpose of this is not to teach you all the circuitry tests and everything like that, but we had 11 volts, so we wanted to go to D2, and it wants us to check for any shorts to voltage on those lines or anything like that, and we had 0 volts. And then we just answered a series of these questions. We have no resistance in the line, and we have no shorts to ground or anything like that. So we want to focus in on here on D5, which tells us what it wants us to do is to go in and start the engine. We're going to look at some PID data on the computer and watch the oil pressure on this engine and see if we see this pressure drops. What we're doing is seeing if the computer is actually controlling the engine oil pressure, and then we'll make a decision from there. So let's go back over to the car and watch that. Okay, so we're back over with the IDS. What we're going to do is we're going to look at a series of PIDs. Or actually just one PID on this car. So what are PIDs? PIDs are, we're going to look in the data logger, and PIDs is what we refer to as a parameter identification numbers or information that we're going to watch. So we're going to open this up. We're going to look in powertrain. We want to look at the engine. Gonna let it boot up on here. And what this allows us to do is to look on many things inside this engine as to what's going on. We can see voltages, we can see percentages, we can see throttle positions, temperatures, an endless number of things that we can watch in the computer here and just kind of see what's going on and see watch it monitor itself. Okay, so these are all a big list of which we can look through here, but we want to just look at one thing here. So we're going to clear these all out, and we want to look at the oil pressure PID. So we're going to look here at EOP, which is engine oil pressure. We're going to watch this pressure, and what it wanted us to do was to watch this pressure, and it wants us to turn it into a graph. Let's watch it on a graph. It'll be easier to watch. And I'll get our trusty assistant Jay to start the vehicle. What it said to do was to start the vehicle, and then you could watch the engine oil pressure PID. Okay. And it says we should see a drop of about 8 psi somewhere within 20 seconds. So let's watch our oil pressure PID. And there we see our drop. Okay. So our answer to the question was, is this working? Yes, it is working. That's where we're just verifying everything's working. Okay, we're going to turn the car off. So this is an example of a situation where the code and the pinpoint test is going to take us down a line that says it's something wrong with that solenoid, okay? Because the only way that computer knows if that solenoid's working is it's watching the oil pressure, and it sees the oil pressure where it wants it to be, okay? Now the circuits all test out good in this car. The solenoid, the next step in the pinpoint test was to unplug that solenoid again and inspect those connectors. Well, we've already inspected those connectors because we've already unplugged that solenoid, and we've checked voltages and grounds to it and everything. So we know that the solenoid isn't suspect, connections, the circuitry, that's not a problem. The thing's working well, and right now it's working just fine. So what in the world's going on with this car? Well, that's where we have to look at everything as a whole, what's going on with this car. That's where the visual inspection came into play. Remember, we saw this car needs an oil change. Remember, we looked at the lube sticker on there, and it says this car's 4,000 miles past due for an oil change. So that means if that oil change was set at 5,000 miles, that means that this thing's gone pretty near 9,000 miles without an oil change. In a modern engine today, they can't take that for two reasons. One, it's going to use some oil, so now the engine's practically out of oil. And two, it's going to sludge up that engine, because remember, that engine oil's purpose is to lubricate, but it also is a detergent. It's also to carry away all the contaminants that are happening in the blow-by from the crankcase, or from combustion, blows past those rings, all that contaminants and all that junk. That oil is responsible for carrying that all to the filter. So now you have a filter that's obviously getting really plugged up, and an all-around mess. So what's happening with this car? Okay, so we have low oil pressure, dirty oil, and this guy's driving down the road, and he's hearing whining noises. Well, what's obviously happening is the engine's low enough on oil to where we could either be hearing the cam phasers rattling around or lifters rattling because he's running out of oil. And once that happens, once it's not making oil pressure properly, the computer's looking, remember, it's diagnosing itself, it's saying, hey, I'm going to turn the oil pressure on to this level, and then we're going to toggle it down to this level. Well, if we don't have proper oil pressure, we're probably never getting the high pressure in the first place, and so what it thinks is that control solenoid is no longer controlling it, and that the control solenoid's a problem. When in reality, what's wrong with this car is it needs an oil change. I mean, simply said, it needs an oil change so that it can have some fresh oil in here, and then once the oil is changed, we can reevaluate how it's working. Chances are that it's going to work just fine. We just need to make sure that the don't have any further damage as a result of not changing the oil. So